Okay, in this video we are going to learn about parallel and perpendicular lines because they have special relationships and you can often find word problems that are asking you about the relationships between parallel and perpendicular lines. We're also going to kind of use this as an excuse to practice some of the skills that we learned in the last video. So if you didn't watch, if you're watching them out of order, like the other video for today is supposed to be first. Okay, so hopefully you've already watched the writing equations in y equals mx plus b form video. All right, so first, if we think about two parallel lines, what's the relationship between their slopes? So let's say that we have this line right here. And then we also have this line right here. They're parallel. I know I did it with a ruler. What's the relationship between their slopes? Well, hopefully you would agree that they always have the same slope, right? They're going up at exactly the same amount. So if one of them has a slope of roughly 2, looks like I did more like 2.5, then the other one's going to be exactly 2.5 as well. So for example, the rule y equals 10x minus 1 and y equals 10x plus 5, they would be parallel because they have the same slope. Okay? Now, what about perpendicular lines? Hopefully we remember that perpendicular means they meet at a 90-degree angle. The relationship here isn't quite as obvious, but it's still there. Perpendicular lines. And the shorthand for that is you do a little upside down T. So I'll often use that. In parallel lines, the shorthand is you do two little dashes like parallel lines. Okay, so you are going to set up a little table for me and we're going to see if you can discover what the relationship is. So slope of line A is going to be the first column in your table and slope of line B is going to be the second one. Set that up now. All right, so I hope you like my super high-tech lines. I've been using the same transparency for years. So I want you to write down what is the slope of line A and what is the slope of line B. Pause, do it now. Hopefully you agree that the slope of line A for this one is 1 and the slope of line B is -1. All right, we can tell it's going over 1 up 1, over 1 up 1, over 1 up 1, 1 over 1 is 1. So it's going over, down, just in the negative direction. So maybe it's the same except one's negative and one's positive. Let's try another one. Okay, I changed it a little bit. Try and figure out what's the slope of A, what's the slope of B. Write them both down. Well, slope A is going over 1 up 2. Over 1 up 2. 2 divided by 1 is 2. Maybe B is -2. That would be convenient. Let's see, it's going over 2, down 1. And that's rise over 1, so that means this is -1 over 2. That didn't work. Let's try another one. Let's see if we can find a different pattern. All right, go ahead and try this pair. I marked in red a coordinate that you can use because I know it can be kind of hard to see sometimes. So on this one, do we see that our y is negative now? And it's going down 3, so a rise of 3, and then a run of 2, so -3/2. And then our b is going up 2, rise of 2, run of 3. Rise of 2, run of 3. That looks sort of patterny. Let's try one more. This time, if I were to do 1/4 for A, what do you think B is going to be? Write it down. So here we have 1/4 for A. And then B is -4. So hopefully you've noticed a pattern here. What's happening is, we would have a great old discussion about this if we were in class together, but we're not, so I'll just tell you that what's happening here is you're getting the opposite reciprocal. So opposite reciprocal slopes. And you might remember that word reciprocal from learning how to divide fractions in 6th grade. When you take a reciprocal, you flip the numerator and denominator. So like on this one right here, we can see that we went from 3/2 to 2/3, but then we also needed the opposite. So what was negative became positive. Now that doesn't super seem to work on these ones, except it does, because we know that any whole number can be put over 1. So let's add just a couple more in here. If I were to give you the fraction, or if I were to give you the slope -6, what would the perpendicular slope be? Hopefully you agree. It would be 1/6, because this is the same as 6/1. You would flip it, so it would be 1/6. And then since this one was negative, the new one would be positive. It's always going to have the opposite sign for the slope, which makes sense, right? If they're perpendicular, they're going to have to be pointing opposite directions. If one's going, they can both be going up or both be going down. And then the reciprocal part is going to flip. Okay, so make it into a fraction if it's not already. So one way to say that would be A/B is going to be perpendicular to -B/A. All right, let's try it out. All right, so let's find the equation of a line that's parallel to y = 5x + 3, and it passes through the point -1, -4. So we know that we have this equation, but that's not the one we want. We want one that's parallel to this. So that means that our new line is going to have the same slope. This is parallel, not perpendicular, parallel. Same slope. Does the +3 matter? Nope, it's extra information. It's there to confuse you. You don't need that, right? That just is telling you about that line. It's not giving you anything. So we're going to say, don't need this. So our new rule is going to be y = 5x plus some unknown y-intercept, right? Because it's parallel to this one, which means it's just shifted up or down. We need to figure out what the new b value is. And fortunately, we have a point. -1, -4, and we can solve for that just like in the last video that you already watched because you're following directions for x, y. So -4 = 5 times -1 plus b. -5 plus b, we add 5 to both sides, and we get b = 1. So my new equation is y = 5x plus 1. Let's do it again, but this time let's say that it is perpendicular. So we're going to use the same numbers. We're going to find the equation of a line perpendicular to y = 5x plus 3 through the point -1, -4. So once again, this, still don't need it, right? That +3, useless information, ignore it. But we don't have the same slope. Now we need the opposite reciprocal slope. So what's the opposite reciprocal of 5? -1/5. Because 5 is sort of like having 5/1. You flip it, you make it negative. Okay, so now I have y equals negative 1/5 x, and I need to figure out what my new b value is. It's not going to be plus 3. I mean, maybe it is, but that would be a weird coincidence. So plus b. And now I'm going to plug in my x and my y from that extra point. So that'll be negative 4 equals negative 1/5 times negative 1, lots of negatives here, plus b, when I solve for b. So negative 4 equals a positive 1/5 plus b. I subtract 1/5 both sides, and I get b equals negative 3 and 1/5. I don't really like mixed numbers, so I'm going to say b equals negative, oh no, 4/5, sorry, negative 3.8. So y equals negative 1/5 x minus 3.8. And so finally, let's go ahead and do your practice problem. So I want you to do the same thing we did on that last example. I want you to find the equation of a new line that goes through the point 2, 4 and is perpendicular to the line y equals negative x plus 5. Now the trickiest part of this is figuring out what's the slope of that line, because it's not just a floating negative, right? It has a real slope with a real number. What is the slope of that line? Find its opposite reciprocal, solve for the correct b value. Go ahead. We'll check this in class on Monday or Tuesday.